All right, so welcome back to everyone. A very, very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, I'm here again, your physics educator, Dr. Umashankar, and we are going to continue with this 75 hard days challenge. Okay, so, guys, in this session, I am here with some more interesting questions of physics, and we are going to deal with those. So, here we go with the first question. So, the live students can try this question and you can let me know if you are able to solve it. Okay, so today I have come up with some questions which will enhance your understanding of this very subject. Okay, so these few questions we have taken from the motion under the gravity. So let's try this question. This is the first question for you guys, and I'm very sure that we can absolutely be able to do it if we have seen the session and if we are good at kinematics. So let's try this question. I'm very sure we can do it. So if this question consists of three parts. Okay, so let's start with the first part. Let's try this question. I'm very sure we can do it. Let's try to do it. Very interesting question. So we were seeing the motion in the straight line. We were seeing the motion under the motion under the gravity, and we will have to see. We must have to see now that what is going to be the solution of it. So basically, it is the application of the motion under gravity. Okay. Now let's try it. So it says balloon. So see, as I say, like in physics, the question may sound a little bit, very practical. Okay. Likewise in this question, so we don't have to afraid. We have to use our concepts that we have learned. So a balloon rises upward with a speed of 10 meter per second. When balloon is at a height of 100 meter from the ground, a stone is dropped from it. Find the time taken by stone to reach the ground. So how it is going to happen? Now please observe. So see, let's try to understand the question. So first of all, like there is a ground. Let's suppose this is a ground. Okay. Let's suppose this is the ground and the balloon rises upward with a speed of 10 meters. So the live student, welcome to the session. You can try this question if you want to first, and then I'll be answering this question. Okay. So it says a balloon rises upward with a speed of 10 meter per second. When the balloon is at a height of 100 meter above ground, a stone is dropped from it. So we have the balloon. Let's suppose the balloon is somewhat like this, and it is at the height of 100 meter. Okay, it is at the height of 100 meter. Okay, now a stone is dropped from it. So let's suppose this is our stone. Okay, let's suppose this is our stone and this is dropped from this very balloon. Okay, when it is at 100-meter height. Now it says that what is the time taken by stone to reach the ground. Okay, to reach the ground. So we are supposed to get the time. Now please understand it. So first of all, you have to imagine what is given in the question, and then you have to use the equations or the learnings we have done. Okay. Now if I say, let's suppose this point is A, from where the stone has been dropped, and this point is B. Okay, that is the ground. Okay, so when the stone is dropped from this balloon, obviously it is going to hit the ground. Okay. Now, if I consider the motion from A to B, if I consider the motion from A to B, what is going to happen? So we have the displacement. What is the displacement? So it is 100 meter. Now, if I take the reference, okay, so what I do, I take the reference from the beginning of motion always. So if I take the reference from A, the displacement is going to be minus 100 meter. How come, sir? Because we know the sign convention of the vectors. So in vectors, what we do, like what we have learned under the motion, under the gravity. So when we have a reference, so any vector which is in downward direction, we take it in negative. Okay, so the displacement is going to be equal to minus of 100 meter, right? Absolutely, so no problem at all. Now this balloon is moving this balloon is moving at a velocity of 10 meter per second. Okay, rises upward with a speed of 10 meter per second. Now, at the moment, now please try to think this. At the moment when the stone is dropped, what would be its initial velocity? What would be the initial velocity? So obviously it will have the velocity of the balloon itself. Okay, now the velocity is upward direction, so it has to be plus 10 meter per second. It has to be plus 10 meter per second. Okay, and acceleration we have, because this is motion under gravity, so the acceleration will be minus 10 uh, minus 10 meter per second square. How come, sir? So we are supposing g to be 10. Okay, as I told you. So like for the ease of simplification of calculation, we assume, and most of the time g is given as 10. Okay, so see, gravity, acceleration due to gravity is always downward. So it is always downward. That means it is always minus 10. Okay, now we have s, we have u, we have a, and we have to get the time. Now, when we have to get the time in the first case, so what is to be done? Sir, we know S is equal to ut plus half a t square, isn't it? S is equal to ut plus half a t square. Now, when S is equal to ut plus half a t square, I can put the values here. So, S is going to be minus 100, u is going to be plus 10. Okay, time we have to get, then this is going to be plus half minus 10 t square plus half minus 10 t square. Is it or isn't it, Vida? Very, very simple, isn't it? Yes, sir, absolutely. Now, from here, we can solve for the t. So, can I write it as this? So, we have 5 of t square. We have 5 of t square plus 10 of t plus 100 plus 100. So, it has to be minus. So, I'll take it to this side. Okay, so if I change the side, so it will be 5 of t square, and let's go that side, it will be minus 10 of t, and it is already minus 100. So can I write t square minus 2t, t square minus 2t minus how much? So 5, 100 by 5, that is 20. That is 20 is equal to 0. That is 20 is equal to 0. Okay. Okay. So we can obviously solve this equation, right? We can obviously solve this equation. And when we are going to solve this equation, we'll get two values of t. Okay. So let's suppose one. So I'm going to solve this equation because I know that all of us can solve. So we want to do as much as questions as possible. So I'll leave it here. Okay, so what is going to be the time? So if you are getting two values, if you are getting the two value, the positive value out of this two value will be your answer. So let's suppose one, I don't know what is the answer. Let's suppose one is, one is, let's suppose plus 3, another is minus 2. So what is going to be the answer? So it is going to be plus 3. So out of the two value of time that you are going to get, you need to take the positive sign. Understood, Bida? You need to take the positive value. So this way you can reach the solution of this question. Now let's try the next part of this question. I'm very sure we can do it. Please go for it, Bida. Let's see if we can do it or not. Let's see if we can do it or not. Please go for it. Please go for it. I'm very sure we can do. So it is maximum height, not weight. Maximum height. Okay. So it was wrongly written here. Maximum height attained by a stone. Please go for it. And this is also needs some. So find the distance between the stone and balloon after 3 seconds. After 3 seconds. Okay. So this is the complete question. Now please let's try this one. I'm very sure we'll be able to do it. Please go for it. Please go for it. I'm quite sure we can do. Maximum height attained by the stone. Now, what does that mean? What does that mean? Now, see what happens. Now, please try to understand this thing. Now, see, at the moment, now, see, please understand this. So, I have used it like this, but for the first case, it was okay, good to go. But, like, if you realize the second part of it, now, see, now, please think in this way. So, balloon is moving upwards. Now, balloon is moving upward, it is having some velocity. Now, the moment when the stone is dropped, it is having some initial velocity that is plus 10. Okay, now to understand the second part. So the why you haven't considered this in the first part? Because in the first part, see, it was irrelevant. Why? Because displacement we are taking now. So displacement when we are doing it is the shortest distance from initial to final position. So it was irrelevant. But in the second case, this is what it means. Now see, there is a ground. Okay, there is a ground. Right now, this is your balloon, and now from the balloon, when a stone came out, let's suppose a stone came out, and it is having some velocity. So it is said na initial velocity is 10 meter per second because when it is dropped, see, realize this thing. This is physics. You have to realize. So in when the stone is moving upward with a velocity of 10 meter per second, and at some height, at some instant, at some point of time, this stone has been dropped. Okay, now, when the stone has been dropped, initially the velocity of the stone is 10 meter per second. So, when initially the velocity of stone is 10 meter per second, so that means it is moving, it will move to some height, okay? Then its velocity will become zero, then its velocity will become zero, then it is start to fall down, right? And this all happens on the same line, but just to I'll take the I have taken the difference just to show you that what is happening, okay? Although you understand this is linear motion, so it goes in the straight line. It is not, we are not considering this thing, okay? Now, do you agree to this or not? Do you agree to this or not? That first of all, when the stone is dropped at this moment, at this point, so as soon as the stone is dropped, since it is having some upward velocity initially, it will move by some distance upward, and afterward it is start to fall down. So what is asked to you, you are asked about it, what is the maximum height it is going to reach. So this what we know, this is 100 mm, this is 100 mm, and now 100 meter, and now if this is let's say x, so we want to find this x, right? We want to find this x, because if x is found, you know that what is the maximum distance this stone reaches from the ground. We'll add this x to the 100 of course. Okay, now let me consider, so this was I have considered b, so let's consider c. Now can I consider the motion between a to c, motion between a to c. Now, if I see the motion between A to C, we need to find this displacement. So what is the information we have? So we have the initial velocity, which is upward, and so upward it is. So I'll take plus 10 meter per second. What is the final velocity? So at the point it reaches the sea. So you are realizing this fact now. So you have dropped the stone. It is having some upward initial velocity. So it will go to some height. Then it will start its downfall, right? Then it will start its downward motion. Okay. So why you haven't considered from C to B, sir, in the last case? Because see, last in the so I have taught the motion under the gravity. So if you are going to see that session on the channel, you are going to realize that in this equation, in these equation, we are seeing the displacement. In these equation, we are seeing the displacement. Okay. So when we are using displacement, we are interested in the final and initial and the final position. So what is going to happen here? So V is going to be 0. V is going to be 0. So A to C. So when A to C, I'll apply. And what is A? So A is always downward. It is minus 10 meter per second square. So if I apply my equation of motion between these A and C, if I apply the motion equation between A and C, so can we use V square is equal to U square plus 2A? So why we are using this? So see, you have final velocity, you have initial velocity, you have the acceleration. So you have to use this. So what is S? S is x here. S is x here, right? So what is going to be the x? It is going to be 5 meter. Okay, so x we have, this is 5 meter. Now when we have this x, what is going to happen when we have this x? So what is the maximum height it is going to reach? what is the maximum height it's going to yield? So it is going to be 105 meter. It is going to be 105 meter. I hope it is fine to you. Yes or no? Okay, the live students, you can tell me. Okay, very, very simple. Again, using the same thing. So if you understand the question properly, if you can visualize the question properly, it is high chance that you are going to solve the question. You will be able to solve the question. Understood, Bida? Okay. Okay, so the live students can respond. Okay, wonderful. Now let's back to the original question. Okay, now let's do the third part of the question. So find the distance between a stone and balloon. Find the distance between stone and balloon after 3 seconds. Okay, after 3 seconds. Right. So now what we have to do? Bataiye. What we have to do now? Please answer me. What we have to do now? Very, very simple. Very, very simple. See, little bit you have to think. You have to realize. Okay. Find the distance between a stone and balloon after 3 seconds. After 3 seconds means what? After 3 seconds from the stone being dropped. So let's suppose at some point of time the stone is dropped. Now at that point of time, obviously the time will proceed. So from some point of time when the stone is dropped, after 3 seconds, what is the difference between a stone and the balloon? Okay. Now let's try to realize this. So see what is happening there. What is happening there? So what is happening? So we have the ground, we have the balloon, we have the ground, we have the balloon. Okay. Now the moment the stone is dropped, okay, stone is dropped. So after 3 seconds, so stone is moving. Let's suppose in the downward direction. So after 3 seconds, see, I don't know. Like it may be in this zone where it is rising. We don't know. Okay, but let's suppose for time being that after 3 seconds. So this is the point where. So let's suppose this is 100, right? So this is the point time where the stone is dropped. Now after 3 seconds, what is going to be the scenario? Let's suppose after 3 seconds, what is going to be the scenario? So after 3 seconds, this stone will be, so it is moving upward. It's sorry, the balloon is moving upward. Okay. So after 3 seconds, what could be the scenario? So the stone, this balloon could be somewhere here. Okay, it is moving upward. So after the stone being dropped, it is still moving in upward direction because it is having a speed of 10 meter per second upward. Okay, so after 3 seconds, let's suppose this balloon reaches somewhere here. Okay, and this is stone, and the stone is at somewhere here. Let's suppose here. Okay, so what we need to get here? We need to get this distance, right? In this third case, we need to get this distance. So the live student, first you tell me, did you get this thing or not? First of all, did you realize that this is asked in the question? Please answer me. Do you realize this or not? So balloon being raised, okay, balloon is going upward. So when balloon is going upward, okay, the balloon is going upward. Balloon is going upward. So after 3 seconds, it will be at some place like above from the initial position. Okay, it will some place above from the initial position. Okay, and this stone will be somewhere in this downward position from the initial position. So after 3 seconds, you are supposed to find this much distance. You are supposed to find this much distance. Okay, I hope this is clear to you. So what we have to find first? What we have to find first? We have to find this distance, that is x1, and then we have to find this distance. Let's suppose this is x2. Let's suppose this is x2. So we need to find this x1 and x2. So how we can do it? So see, let's consider for balloon. For balloon. Okay, so I'll talk about balloon first. So now this balloon, it is at this position, that is, let's suppose A, and it is at this position, let's suppose B. Now I am considering the motion of balloon from A to B. So basically it is written that it is having an upward speed, but it is not mentioned about the, any change in the speed. Okay. So see, in the case of balloon, we are not going to consider the gravity. Okay. So why you are not considering, this is happens now. In general, what happens that when we throw the balloon out in the atmosphere, it rises. Okay, it rises. So see, gravity doesn't work on balloon, or we can say it works, but we neglect the effect of it. Okay, we if neglect the effect of it. Now, in 3 seconds, if we say, so see, like the, so remember this also, in the case of balloon, you need to let go of this, gravity thing. Okay, because it happens to, move in influence of some force, right? Are you getting my point? Okay, like some gas is inside or something like that. So we don't take consider gravity. So now from A to B, what is going to be this x1 distance? So we know displacement is equal to ut plus half at square. So half at square A is 0. So simply we can say x1. So what is it? 10. And how much time it took? So after 3 seconds, so this is 30 meter. So basically you have this x1. You have this x1 now, which is 30 meter. So from the initial position from where the stone has been dropped, this has reached the 30-meter mark from that point. It is in a position 30 meter above from that point. Okay, but the stone is what? Stone is x2 downward. Now for stone, now let's suppose we are going to apply the for stone. Now for stone, what happens? So stone will have the influence of the gravity. So now what is going to be this x2? So x2 is ut plus half a t square, ut plus half at square, isn't it? X2 is equal to ut plus half at square. Now can we write x2 is equal to, so 10 into 3. So how this is 10? So initial velocity is upwards now. Initial velocity is upward. Okay, sir, but sir, how we know that this x is going to be positive? So if at all our assumption is wrong, this is going to come out to be negative. Let's see that. So this is going to be 10 into 3 plus half. What is this a? This is minus 10, and this is 3 square. This is 3 square, time is 3. So this is going to be 3 square. So from here, what is this x2? So this is going to be 30. This is going to be 30, and this is going to be see, 5 into 9, that is 45. So minus 45. So x2 is going to be minus 15. X2 is going to be minus 15, and we are getting it in minus. That means our assumption is correct. How our assumption is correct? Because see, if it is upward, it would have come into positive thing, because we know from the reference the displacement, if it is downward, then obviously, if the displacement is downward, then obviously what happens? Obviously, what happens? So if the displacement is downward, the it would have come to be negative, and if it is upward, it has come out to be positive. Okay, so after 3 seconds, this is 15. So after 3 seconds, what is going to be? So what is asked in the question? So it was asked to find the distance between a stone and the balloon. So what is going to be the distance between a stone and a balloon? So it is going to be 30 plus 15, that is 45 meter. This is going to be 45 meter. I hope it is fine to everyone. Okay, very interesting question, isn't it? Okay, so live student can tell me if you have any doubt in this case. I hope we do not have any doubt here. Yeah, I hope we do not have any doubt here. What do you think? What do you say? Right, sir. So let's move to the next question. I'm very sure we can do it. Okay. So moving to the next question, let's try this one. Okay. So let me write one question. One interesting question is there. So just a moment. So because I think this is missed to be typed. So a stone dropped from a stone dropped from the top. It's a good question. Of the tree. A stone is dropped from the top of the tree. Covers of the tree covers 6 meter height. Covers 6 meter height in last 0.2 second of fall. Okay. Find the height of the tree. Find the height of the tree. Let's try this one. Correct. We need to find the height of the tree. Let's try this one. Let's try this one. I'm very sure we can do it. Very simple question, brother. Please tell me. Correct. How we can do it? So now what does this question say? So it says a stone is dropped from the top of the tree, covers 6 meter height in last 0.2 second of fall. In last 0.2 second of fall. Find the height of the tree. Find the height of the tree. Okay. Find the height of the tree. Okay. Okay, now please understand this. See, always what you have to do. See, in physics, this is very, very necessary that you realize the question first. That what is the question and how we can proceed to it. What is the information given? See, if you can draw a small sort of a figure, then obviously it is going to be helpful a lot. So the live student, have you attempted this beta? So let's suppose we have a tree. Okay, let's suppose we are having a tree. Okay, we are having this tree, and now from this tree this falls. So let's suppose a stone is dropped from here. Now a stone drops, like it is going to reach the bottom obviously. So it says that the tree, the from the top of the tree, covers 6 meter height in last 0.2 second. Okay. Okay, so like in 0.2 seconds. So let's say that from this, let's suppose this is A and this is B. This is A and this is B. Now, what is the time? What is the time it took from A to B? So from A to B, it let's suppose took T t seconds. Let's suppose it took t seconds. Now, if it is taking t second in the last 0.2 seconds, so this is in the last 0.2 seconds, so it has covered a distance of 6 meters, right? This is what is the information says. It covers 6 meters. So this is 6, let's suppose. This is 6 meters. Okay. Now, if the height of the tree is h, if height of the tree is h, what is going to be this distance, beta? What is going to be this distance? And obviously, this is going to be h minus 6. This is going to be h minus 6. Do you agree or not? Please answer me. Do you agree or not? Yes, sir. Of course, we agree. Of course, we agree. Now, how we can try this question? How we can proceed with this question? So, see, let's apply. What is the information we have? We have something of time, and we have the acceleration due to gravity. So let's start with the question. So see, I am considering the motion from A to B. I am considering the motion from A to B. Now, when I consider the motion from A to B complete, what is the displacement? So this is going to be minus h, okay, because it is from the reference from A point, it is downward. So this is going to be minus h. Now ut. So what is the initial? What is the initial velocity? So it is dropped with obviously zero velocity. So 0 of t and plus half. Now acceleration is always downward, minus 10 t square. Okay. Okay. So from here, what we are getting h is equal to 5 t square. So we have got some relation between this h and 5. Okay. Okay. Now let's process the next information. Let's process the other information. Okay. Now please tell me, like from this point A, let's suppose this point is C, and this point is point 2, so the time here is t minus point 2, isn't it? Okay, so see, from the height from the tree, it reaches the ground in t time. And in last 0.2 second, what is the height it covered that is given to you? That is 6 meters. Okay, that is 6 meters. So now in this case, so it reaches from A to C obviously in t minus zero point 0.2. So if I consider now the motion between A to C, the motion between A to C, can I write that the displacement is going to be minus h minus 6? Why so? Because it is downward. What is the initial velocity? 0. What is the initial velocity? 0 plus half. So 0 into t will become 0. Okay, I'll write it. Plus half, acceleration is always downward, and this is t minus zero point 0.2 whole of square. T minus zero point 0.2 whole of square. Yes or no? Now the question is solved. How sir it is solved? Because now you can see that we have made two equations between h and t. See, this is the simple funda. I told you every time in my sessions also that whenever you have two variables to find out, whenever we have two variables to find out, okay, you always try to develop two relations between two variables. So two equation, two variables, two equation, two variables. So when you have two equation and two variable, what you are going to yield? You are going to get the two variable solved. Okay. Okay. So you are going to get the two variable solved. Okay. Clear? Okay. So now solving this equation, you can get h. Okay. And see, you can cross check it. Okay. Because I loosely have solved it. So this will come out to be 48.05 meter when you solve these two equations, and obviously then you can get the value of h and t both. Okay, so when you are going to get it, you are going to have this as your answer. You are going to have this as your answer. So I hope it is fine to everyone, beta. Right? Right? Please tell me if it is okay or not. Yeah? Yeah? Now let's try one more question. See, these all are the questions of motion under gravity. So this topic we have completed lastly in the last session, and today I'll be starting with the projectile motion also. Okay. Let's try this one. I'm very sure you can do it. Please go for it. Please go for it. The live student can tell me the answer in the chat. Please go for it. Very good afternoon, Shivesh. How are you doing? Hope you are well, my dear. Where have you been? Let's try solving this question. So in the last session on the channel, I have completed the motion and the constant gravity. So with this session, we will be solving some question of that topic we are trying to solve. Okay, because we want to get better understanding of the topic. So I have come up with some questions. What is the answer to this question? Can you please try it? Let's try it. Any answer? So I had this typed, but I missed to. Well, just keep it here so that you can use for the later. Uh, Please try solving this question. Very simple, in the same direction we can do as we have done the last question. No. So it says a stone is dropped from rising balloon at a height of 300 meter above the ground and it reaches the ground in 10 seconds. The velocity of the balloon when the stone was dropped is. So how we can try it? So a stone is dropped from rising from a rising balloon at a height of 300 meter above the ground and it reaches the ground in 10 seconds. Okay, so how it is going to be? See, again, let's draw the figure. So we have a balloon, okay, which is obviously rising at a height of 300 meters. So at the height of 300 meters, let it be 300 meters, the ground, and it reaches the ground. So a stone is dropped from here. A stone is dropped. Okay. Now we know that it's going to have some upward speed, velocity. So like from here, so no velocity is mentioned. So we can consider. So now see, this is a stone is eventually going to strike the ground. So I'm considering the motion between A to B. So velocity of the balloon when the stone was dropped. So you are supposed to find the initial velocity. Okay, you are supposed to find the initial velocity and what is given, time is given. So see how we can do it. So see what is from this reference, what is from this reference. So if I consider the motion between A to B, so can you understand that the displacement is given, it is minus 300 meter. Okay, time is given, that is 10 second, and acceleration we have, that is minus 10 meter per second square. So why you are taking this as minus? So I am taking this as minus, I am taking this as minus because you see what we have considered. So we have considered it from some reference, we will take the downward from the reference, like from A, the displacement happened to be in the downward direction. Okay, acceleration is always downward when it is due to gravity. Okay, so we have considered, we have taken this assumption that we have taken this sign convention, right? Now we understand that S is equal to ut plus half a t square. So what is this S? This is going to be minus 300. This is going to be u, and the time is 10 second, and this is going to be minus. I'll put here 10 minus 10 So it will become minus into 10 into 10 square into 10 square. So what it is going to be? What it is going to be? So we have considered this as uh, you know 10. Okay. So 10 we have considered. So 10 we have considered, although it has to be 9.81. So G is 9.81 basically. Na? So because see the options are 19, 19.6, so we can consider 9.8. Okay, 9.8. So from here, what is the U we are getting? So when we will be solving it, you will be getting to see it will become, so 9.8 into 100. Okay, 9.8 into 100, so that is 980. Okay, 9.8 into 100. Okay, it is going to be 980, isn't it? Isn't it? So 9.8 into 100, 980 by 2, 980 by 2. So this is going to be 490, and 490 minus 300. 490 minus 300, it is equal to 190. 190 by 10, that is 19. So when you solve this equation, you will be getting option A, that is 19 meter per second. Do you understand this or not? Please answer me. Please tell me. Please tell me. Please answer me, my dear. Did you get this question or not? Shivesh, please tell me now. Did you get this question or not? Uzma, very good afternoon, beta. So, Uzma, in the last session, we have done the motion and then the gravity. So, in this session, I came up with some questions of those motion and the gravity. Okay. So, since you have joined late in the session, I suggest that you must watch the recording once. Okay. Okay. Will you be able to do that? Okay. So, let's see some more questions. Let's see some PYQs then. Okay, now I want you to solve this previous year question from this particular part. Okay, so these questions were I wanted to do in the regular session, but due to the time constraint, I didn't do it. So I did it in this session. Now let's try this one. Please go for it. I'm very sure we can do. In the same process, Shivesh, you also, beta. Very, very simple. Let's try this one. Let's try this question. Please do it. You have given some answer. Very good, Beta. Very good. What about you, Shivan? What about you? So what does this question say? It says the ball is thrown vertically downward with a velocity of 20 meter per second from the top of the tower. Okay. So we have a tower. Now from the top of this tower, this ball is thrown vertically downward. And so if I consider this is A and this is B. Yeah, perfect. So I'll consider the motion from A to B. So what is the initial velocity? It is 20 meter per second, and it hits the ground after some time with a velocity of 80 meter per second. So final velocity is 80 meter per second. G is minus 10. Okay. So what is the height of the tower? So which equation we can use? Simply V square is equal to U square plus 2AS. Okay. So V square is what? It is 80 square. Okay. U square is what? It is 20 square. So downward it is. So I'll write minus 20. It will also be downward. I'll write minus 80 plus 2 into minus 10 into S plus 2 into minus 10 into S. So what are we getting, Beta? So 80 square minus 400. 80 square minus 400 plus 2AS. So when we solve this equation, what are we getting? When we solve this equation, what are we getting? So we are getting, see, so it will become 6,400. This is going to be 400, and it is going to be minus 20 of S. It is going to be minus 20 of S. So this is going to be 6,000 by 20 with a minus sign. So S is going to be minus 300 meter. And why minus is coming? Why minus is coming? Hello, she said. Why minus is coming? So minus is coming because it is downward. Okay, so Shisha, we have solved some very good questions. So in the last session of motion and the gravity, I wanted to give you these questions, but I couldn't due to some time constraint. So I have solved the motion under the gravity, some good questions here. Okay, so please refer them. Okay, once. Okay, okay. So let's move to one more question. So this is the PYQ, very simple PYQ. Na? Let's see if I have any more. This is extremely simple. So let's try this one. What is going to be the answer? Uzma, you also please tell. This is an extremely simple question. Yeah, she's right. How about the rest of you? Very good, Uma. Let me do it. So it says a boy is standing at the top of the tower of 20-meter height, drops a stone. Okay, very well. So there is a boy who stands at the top of the tower, okay, which is 20-meter high, which is 20-meter high, and he drops a stone. Okay. So when he drops the stone, obviously it is going to reach the ground. So this is going to be A, this is going to be B. So a boy is standing at the top of the tower of 20-meter high, drops a stone. So initial velocity will be zero. Okay, initial velocity will be zero. It is going to reach the bottom. Okay, the velocity with which it reaches the ground. So acceleration is going to be minus 10. Acceleration is going to be minus 10 because it is always downward. Root 2gh also you can use. Okay. Okay, but I prefer this way because you can solve each and every question. Na? That also coming from this only. Na? A is equal to minus 10 meter per second. So we know V is equal to U plus 80. Okay, V is equal to U plus 80. So what is going to be the final velocity? It is going to be V and this is 0. A is minus 10 and T is, oh, so it is height is given, not time is not given. Na? So we are going to use S is equal to ut plus half a t square. So u is equal to 0, S is equal to minus 20. This is going to be minus half into 10 t square. Minus half into 10 t square. Yes or no? Okay. What I am doing. So from here we can get the time first, right? Or why I am using this equation. Just I was seeing another question and which give question to give. Sorry. So v is why we can't use v so we have to find the final velocity. If v square is equal to u square plus 2s, right away I can use this equation. Okay, so initial velocity is 0. This is going to be v square plus 2 a is minus 10 and displacement is going to be minus 20 because I have taken the reference from a. Right. So this is going to be V is equal to 400. Yeah, she's right. So this is going to be root 400. So 20 meter per second. That is the B option. Right. Okay. So I think you will be able to do these kind of a question. Now let me give you one more question. So I was just trying to look out for the more questions which may interest you. Most of these PYQs are very, very easy, na? Right? Let me give you one more question. Just a moment. Huh? So first tell me if we have done this in the main sessions or not. Just a moment. These questions are extremely simple. No? So in the upcoming session, we will be dealing with the projectile motion today because lastly we have done this thing, this motion under the gravity. This one. Yeah, just a moment. Chalo. Let's try this one. Let's try this one. Let's see if we can do it or not. Also, I teach everyone personally only here, no? It is basically see all the sections are governed like how the live students are responding. Okay, so if you guys are able to solve these questions very easily, then what is the use? It's just a waste of time, right? Okay, although like we have to do PYQ, so two purpose can be served. Either to improve the time, if you are able to do it, I won't solve it. But if someone later sees the video, so I have to whatever question I'm doing the session, I have to solve it. Yeah, yeah, I'm giving some time. Don't worry. I'll just see the question. So something is missing. Just a moment. Now he moves 5 meter towards east and then 2 meter towards north. Okay, 2 meter towards north. Oh, so the sometimes typing people na, they messed with the question. Now he moves 2 meter towards east and then 2 meters towards north. I'll just make the correction. Just give me a moment. Towards the north. You never trust people who are just typing north and reaches. Just a moment. I'm sorry. And reaches a point B. Just a moment. Huh? This question is incomplete. Now it is complete. Uzma, just please be just wait. This question is not complete. How you are able to do it? It is not complete now. Just really sorry for this. See, sometimes things happen this way because obviously I give someone this to type all these things. Now they make the typographical error. No, no, just wait. Just leave this. Just leave this as it is. What I'm doing. Just a moment. Huh? Yeah, now you can go. I made the necessary corrections. Please go for it. Please solve it. Please be careful. Now, the question was wrong. So you just find the magnitude of the displacement here. Sorry. Please do it. We have another session to go. From the first pole, array, it messed up. See what happens. I'll just explain this question to you. I'll just explain. I'll explain. I'll explain. Where is the bird? See the typer who has typed this question has swollen the bird inside. Are you getting my point? He made a mess of it. Are you getting my point? See? Okay. On a horizontal flat ground, a person is standing at a point A. I'll explain, then we can solve this question. See, it's messed a lot. On a horizontal flat ground, a person is standing at a point A. At this point, he installs a 5-meter long pole vertically. Okay, so there is a person. He stands at some point A. Then he installs a pole 5-meter long vertically. Okay, now he moves 5 meter towards east and then 2 meter towards the north and reaches a point B. There he installs another 3 meter vertical pole. A bird flies from the top of the first pole, top of the first pole, top of the first pole to the top of second pole, to the top of second pole. Find the magnitude of displacement of the bird. Okay, first pole to second pole. Right now, please do it, yeah. Finally, so we have another session to go. Yeah, very good. So simply if we can draw the diagram, then we have to find the displacement vector. So on a horizontal flat ground, a person is standing at a point A at this point. So let's draw the diagram. So we have a plane, let's suppose, okay, and a person stands at a point A. So let's suppose this is your X, Y, and Z. Okay. So he stand. Thank you, Adi. So now at this point A, he installs a 5 meter long pole. So there is a pole which is 5 meter long. Okay, okay, very well. So he installs a 5 meter long pole. Wonderful. Now from this point A, he moves towards the east. Okay, how much he has moved towards the east? He has moved 5 meter towards the east, and then he has moved 2 meter towards the north. So 2 meter towards the north, that is this, and reaches reaches the point B. So this is going to be your point B, and here he installs another pole. Here he installs another pole, 3 meter of 3 meter height. Here he installs another pole of 3 meter height. Okay, another pole of 3 meter height. Okay, now a bird from this point flies to this point. Okay, so what is going to be the displacement of it of the bird? So basically it is going to have a displacement of this, that is the displacement vector. So if I make A, I make B, so this is going to be the displacement vector. So what is going to be the coordinate of it? It is 0, 5, 0, isn't it? How so? Because see, if I take A as the origin, okay, so it has only this point A has only this, 5 of this placement, right? This 5 y coordinate. Now, if I see this B, what is going to be the coordinate here? It is going to be 5. That is because it has moved in positive x, that is 5. Then we have what is the vertical? It is the y, that is 3. And what is z? It is -2 because it has moved in towards the north now. So this is the positive z. So this is going to be the negative z. Okay. So these are the coordinates of this A vector, A point and B point. Now what is going to be? Now what is going to be the A and B? What is going to be the displacement vector AB? Okay. 5, 3 and -2 beta. Because this is minus negative z direction, isn't it? Hmm? So what is going to be the AB vector? It is going to be, see, x coordinate of B minus x coordinate of A, I cap, plus x coordinate of B minus, sorry, y coordinate of B minus y coordinate of A, j cap, and uh, z coordinate of B minus z coordinate of A, k cap, right? This is how we find the displacement vector. You can first find the position vector of point A and then position vector of point B, then you make difference of it, or you can use like this, you can do like this. So it will become 5 I cap minus 2 j cap. So Ujma, if you remember, in the last session we have done a question like this. Okay, I hope you remember that, na? Right? Okay, I think it was on Unacademy app. Okay, so now this is what's going to happen. This is what is happening. So from here, what we can write? From here, what we can write? So we can write what is the magnitude. So magnitude is going to be obviously root over. Yeah, it has asked magnitude. Otherwise, it might have made you might have made a mistake. 2 is square plus 2 is square. So this is going to be 25 plus 8, that is root 33. Root 33. So what is going to be the answer? This is going to be the answer. Right, Buddha? Okay. So, guys, I hope this is clear. Udma, this is clear to you, na, Beta? I have done it a little bit fastly because I have another session to take, na? Projectile motion. If it is not clear, you tell me, I'll explain again. No worries. And to other students also, Beta. Is it clear or not? Please answer me. Can we say it is clear, Buddha? Can we say it is clear? Yeah. Just have written the coordinate. If you have the coordinate of 2 points, you can easily get the displacement vector. Right? Okay, wonderful, wonderful. So see, that will be all in this session. We have another session to go. So I'll start the next session at 3:30. Okay. We are going to talk about the projectile motion in that. That is nothing but extension to the motion under the gravity. So I'll just give the basic of projectile motion. Okay, because see, when we are doing the gravity, so projectile motion shall come after the relative velocity in 1D if I go in the right sequence. But let's go of the sequence. No, no, Uzma, we are going to have the next session now. I'll explain the direction. See, my dear. See. So now this A has no issue now. Okay, and I'll just explain the position. See, let's assume a plane. Let's assume a ground. Let's assume a plane. Okay, this is X, this is Y, this is Z. Okay. Now someone is at some point A. Now I have assumed this direction. So basically this refers to XZ plane, right? Like the ground, isn't it? Yes or no? I assumed it as the ground, right? Now it moved from this point A. So he has a pole. So pole I have taken parallel to Y, isn't it? Pole I have taken parallel to Y. So pole is parallel to Y. So this is my origin. So it will be 0, 5, 0. Now do you have any issue with this? Let's call it P. Okay, I have called it A. I mean that's okay. This is, let's call it P, right? No problem. Now from this point A, someone moved 5 meters towards east. So do you realize that he has moved in positive X direction? Yes or no? Right, sir. Now from here, it took 2 meter north. So 2 meter north. So from here, it goes like this now, 2 meter. Now Z direction, positive Z direction is this. So from this point to this point, you have moved in the negative Z direction, no? Right? And then you have installed a pole here. Then you have installed a pole here. Okay. And let's suppose this is Q. So this is going to be 3 meter. This is going to be 3 meter. Right. So this will become 5, 3 and minus 2. Right. Understood? No doubt. Now once you have, see, we have talked about it. So you can go and check the session of position and displacement vector. If you have still any doubt in this question, so once you have coordinates of 2 points, then this is like, you know, eating butter toast, right? Very, very simple afterwards, right? So guys, that will be all for this session. We have done a lot of things in this session. We have done quite a good questions in this session. So I'll come up with this more questions in the next session, but today we have to do the projectile motion. So I'll be starting with the projectile motion like at 3:30, 3:35, let's say 3:35, because I need some 10 minutes now just to relax my throat, right? Okay, so I'll start at 3:35. The next session, please don't miss that session. We'll be talking about the projectile motion on primary level, because I believe projectile motion is nothing but the application of motion under gravity. We'll be using the same equation, same concept. I'll be developing some good formulas. Okay, and we'll be then complete the projectile motion afterwards. Okay, just give you a touch that how motion under gravity is going to be used there, and that is the topic of motion in 2 dimensions. So when we have completed the vector and all this, we can together we can do. Okay, so let's start the next section at 3:35 sharp. So with this,